What is experimentation? Experimentation is the action or process of trying out new ideas, methods, or activities. When doing an experiment, you need participants. However, the participants need to be sorted into different groups. Usually, there will be a control group and an experiment group. The control group does not receive a treatment, but is still important since the experimenters will compare the control group's results with the experiment group. The experiment group, however, goes through the treatment. After comparing the results, they will be able to see whether the treatment had an effect or not. But how do we sort out the participants in a fair way so that both groups can be comparable? We do this by random assignment. Random assignment is the process of assigning participants randomly. This sounds exactly what it means, but the point of this procedure is to ensure that each participant will have the same probability to be assigned to any given group. Examples can include a coin toss or drawing out a name from a box. However, since random assignment is used to assign participants to the control or experiment groups, random sampling or random selection is used to choose the participants to be used for the experiment. So you can say that random sampling goes first. It chooses its participants, and then random assignment divides those participants into their respective groups. An experiment includes a cause and effect relationship. An example of a cause and effect relationship is when a psychiatrist wanted to find out if a certain medication affects a patient's mood. There are four main elements to this process. Number one is manipulation. This is used to create two or more treatment conditions. Number two is measurement. The results or scores of the participants will be measured. Number three is comparison. The scores of different groups are compared to each other to see if the manipulations have caused a difference in results. Number four is the control. All the extraneous variables, all the variables that we're not focusing on, are controlled. This is so that those variables will not influence or affect the manipulations we have done. How will we use these basic elements in the example given? Firstly, after random selection and assignments, we move on to manipulation. This is where one group of participants receive treatment and the other group receives no treatment whatsoever. This is also called the control group. Next is measurement. We can measure the mood ratings that the participants gave. Note that all groups' mood ratings are measured. Thirdly is comparison. This is where we compare the scores of the experiment and control group. Let's say that the participants in the experiment group had a higher average of mood ratings than the control group. We can then say that if the participants receive the medication, it will lift up their mood. Control is important in this experiment so that the results will be more fair. For example, the participants in the experiment need to have a current mood rating of 7 out of 10. If it is higher or lower than 7 out of 10, then the participants cannot take part in the experiment. There are some important points to take note of during manipulation. The experimenters don't choose which participants will have the treatment and which won't. Random assignment is used here, as explained before, to make a fair distribution. There are different types of manipulation, some which include instructional manipulation, which is when participants are instructed to do a task, and environmental manipulation, where the results depend on the strength of the independent variable. Also make sure that when manipulating the independent variable, you do pilot studies, which is like a pre-test, and a manipulation check to confirm that the participants have indeed received the treatment. So an example of an experiment is a professor who wants to measure how well people can focus while listening to certain types of music. The experiment will be done by randomly separating the participants into different groups. Their scores will be measured by answering a test. Higher scores would mean it was easier to focus. Note that the independent variable is the type of music, which means we have manipulated that variable into different genres so that we can get a clear comparison when measuring the dependent variable, which is the score they get on the memory test. Let's say that the group listening to Mozart had a higher average score compared to the group that was listening to pop music. We can claim that listening to Mozart is less distracting than listening to pop music. I always wondered how experimentation will help us in our lives. It seemed that it was just some fancy scientific processes that people do to claim that they are smart. I, however, realized that experiments can help the world in a big way. The knowledge gained and solutions made to create differences in results can impact us positively. If there were no experiments on which medication is good for a certain illness or what things makes people happier, only few of us will know what to do when we are sick or sad or upset. Experiments have shown that people who exercise more are less stressed. People who have more enjoyable careers are more content. With this kind of knowledge, we can choose for ourselves what is good and healthy for us. Maybe you might make decisions such as choosing the career where you travel more over the job with a high paycheck. Maybe you will make more time to go to the gym instead of smoking. This generation also faces many environmental challenges. For instance, if we're running out of land for agriculture, experiments can be done to evolve the way we farm. I saw that in Singapore, they are planning to build high-rise farms and experimenting on how they can develop crops that can grow without soil or sunlight. It's all a balance at the end of the day, but I now see the point of experimentation to create and find solutions for the betterment of society. Now that you know the basics of experimentation, I'll go into more detail about randomization of treatments and explain how logical fallacies are also important. There are two types of experimental designs. There are between subject designs and within subject designs. In between subject designs, there are different participants for each treatment group. This means that the only fair way to divide those participants into their groups is through random assignment. For within subjects designs, it is the same set of participants for each treatment group. This means that random assignment is not really needed. Only random selection was used to get the whole set of participants. But how does random assignment make the experiment fairer? This is done to get rid of any variable that experimenters are unaware of. Let's say that a professor wants to divide his class into two for his experiment, but does not use random assignment. He might choose his favorite students or top class members to be in a certain treatment group, and this might lead to a slightly biased or buff set of results. This makes the experiment less accurate. Random assignment is the best known method for dividing participants into their respective groups. Logical fallacies. What exactly is a logical fallacy? They are usually arguments or judgments based on poor logical thinking. Experimenters can fall into the trap of inaccurate reasoning. It is therefore important to know that logical fallacies are there for us to double check if we as experimenters have made a false hypothesis. I'll not go through all the logical fallacies, but will give a couple examples. One is called defective induction. This is when you see a pattern in an experiment, but then assume that the pattern will be seen in all other experiments. For example, the plants did not grow in that environment. You assume that if other experimenters will do the same thing, they will get the same failed result. But there is a possibility that the experiments will succeed and that you did not consider other factors that might have caused your plants not to grow. One more example is irrelevant conclusion. This is when you ask a question but then proceed to answer a different one. Even if it's related to the original question, it is not the conclusion or answer we are looking for. For instance, the question was, does sunlight cause wildfires? But then to proceed to answer the question by saying that wildfires tend to occur in dry areas. Although the answer may be correct, we were looking for the yes or no explanation of wildfires being caused because of sunlight. The last question that I thought of was, how do we get reliable results from our experiments? What makes us so sure that the results that we get are in fact accurate? I believe that every small detail in experimentation counts. Fairness is really key. As discussed earlier, the only way to make an experiment fairer and more reliable is by being able to control all extraneous variables. We can't always have a perfect experiment with no variables that will affect the results, but we can always try to do so. The less factors that influence the numbers, the more true and unbiased the experiment is. We don't get results without going through the process, so I will make it a goal to produce the most accurate results by putting in the effort to double check if I have assigned participants correctly, made sure that I have manipulated the independent variable so that there will be a more significant effect, and lastly to measure and compare the results carefully. The more reliable our findings are, the more chance that the things we do will succeed, or rather have the same results as experiments.